Hello class, in this video I'll be using the sum and difference formulas of sine to find the exact values of the sine of 15 degrees, the sine of 7 pi twelfths, and the sine of 50 degrees times the cosine of 20 degrees minus the cosine of 50 degrees times the sine of 20 degrees. Let's begin. So the first example, we want to find the exact value of the sine of 15 degrees. And you will notice that 15 degrees is not a standard angle on a unit circle. However, I can write 15 degrees as either the sum of two angles on the unit circle or the difference of two angles on the unit circle. And I'm going to choose the difference, because I know that 45 degrees minus 30 degrees is equal to 15 degrees. So the sine of 15 degrees is equal to the sine of 45 degrees minus 30 degrees. And that is equal to the following. If 45 degrees is alpha and 30 degrees is beta, we have the following. Again, where 45 degrees is alpha and 30 degrees is beta. Now all that's left is to find the exact values of these four trigonometric expressions. So the sine of 15 degrees is equal to the sine of 45 degrees, which is the square root of 2 divided by 2, times the cosine of 30 degrees, which is the square root of 3 divided by 2, minus the cosine of 45 degrees, which is the square root of 2 divided by 2, times the sine of 30 degrees, which is 1/2. So that is equal to the square root of 6 divided by 4 minus the square root of 2 divided by 4, which is equal to the following. Okay, next example. Sine of 7 pi twelfths. Okay, so the sum and difference formulas, they do work with angles that are in radian measure. It's just far easier to convert the radians to degrees. And 7 pi twelfths, that is 105 degrees. So I'm now going to find two angles on the unit circle that either subtract to give me 105 degrees or they sum to give you 105 degrees. And I'm going to pick 60 degrees plus 45 degrees, because that will equal 105. So the sine of 105 degrees is equal to the sine of 60 degrees plus 45 degrees. And that is equal to the following. So since we have a sum of two angles, we're going to use the sum formula. And now all that's left is to find the value of those four trigonometric expressions. So the sine of 105 degrees is equal to the sine of 60 degrees, which is the square root of 3 divided by 2. Cosine of 45 degrees is the square root of 2 divided by 2. And then we're going to add cosine of 60 degrees, which is 1/2. Sine of 45 degrees is the square root of 2 divided by 2. And this is equal to the square root of 6 plus the square root of 2, all divided by 4. And finally, sine of 50 degrees times the cosine of 20 degrees minus the cosine of 50 degrees times the sine of 20 degrees. Okay, so since we are subtracting the product, I'm going to use the difference formula because the difference formula has a subtraction between the two products. So we want to subtract alpha and beta. So I'm going to label 50 degrees alpha, and I'm going to label cosine of 20 degrees, or 20 degrees, I'm going to label that beta. So this is equal to the cosine of, sorry, not cosine. This is equal to the sine of 50 minus 20, which is equal to the sine of 30 degrees. And what is the sine of 30 degrees? Well, that is 1/2. So we know that sine of 50 degrees times the cosine of 20 degrees minus the cosine of 50 degrees times the sine of 20 degrees is equal to 1/2.